In this video, I'll talk about section 8.5 from the book, which is partial fractions. Okay, so in the past, we learned about different techniques of integration. One technique was U substitution method, another technique was integration by parts, and also we learned trigonometric substitution or trig substitution, right? So this partial fraction technique is another technique for integration. So what it does, it is basically separate the complicated fraction into several simpler fractions that are easy to integrate. Okay, that's the goal of the partial fraction. So it will, for example, look at this one. So you see that there is fx over gx times hx. There is a product of two functions in the denominator. So we will find out a way to separate them. Okay, we will find out a way to separate these two functions, like something. So like some function over gx, and then plus or minus, and then another function over hx, like that, so that they will be easy to integrate. Okay, that's the idea. So before I go to the integration, what I'm going to do is I'm going to introduce, there are certain rules to do the partial fractions. Okay, I will introduce some rules, and also I will show some examples based on those rules. Okay guys, all right. So first of all, what do you mean by proper fractions and what do you mean by improper fraction? In the algebraic expressions, if there is a rational function, it's called the rational functions, right? Because if there is x in the numerator and x in the denominator, that will be rational functions. Okay, so when the fraction, or when that the rational function is proper, and when does it call improper? Okay, the proper is the one if the degree of the denominator is bigger, if the total degree of the denominator is bigger than the degree of the numerator, then it is called proper. Meaning, if there is a bigger exponent on the denominator than the exponent in the numerator, that is called the proper fraction. Okay, but if the degree of the numerator is bigger than the degree of the denominator, or if the degree of the top and the bottom are equal, then we call improper fraction. Okay, so the partial fraction is for the rules are for the proper fraction, meaning the top degree is smaller than the degree of the bottom, then we use these rules. But if the degree of the top is equal to the degree of the bottom, or degree of the top is bigger than the degree of the bottom, then in that case you will have to do the long division first. Okay, and then we will use the partial fraction for the remainder term, if there is any remainder. Okay guys, all right. So let us see the rule. How do we separate the factors in the denominator into different factors, or the different fractions? Okay, that's the goal. All right, rule number one: if the denominator contains non-repeated linear factors. What do you mean by linear factor? The degree 1 factor, right? You see that the denominator has product of 3 factors. They are all different. One is x minus a, another is x plus b, another is x minus c. They are not repeated, right? And also they are all linear. Then how do we separate them? Is no worry what is in the numerator. So it is a proper fraction, meaning that the degree of the bottom is 3 here, but there are like dot, meaning there may be more than that, and degree of the numerator is less than the degree of the denominator. That's why it is proper. So we are assuming that. But in that case, how do I separate them? Is, don't worry what is in the numerator. You write a over x minus a plus b over x minus b plus c over x minus c. What did I do is, a, b, and c are any constant you can take. You can write m, n, o, whatever you want to write. Okay, you do a constant a, b, c, whatever you write, a constant over the first factor, plus another constant over the second factor, plus another constant over the third factor. So I wrote a small a, b small b. It is just by coincidence. Okay, you don't have to have whatever there is there. You don't have to have that. It's just a constant. Okay, that's what you do. Okay, so if the denominator, or if bottom of a proper fraction has non-repeated linear factors, then to separate them, what we do is we write a over x minus a, b over x plus the second factor and c over third factor. And how do I find out a, b and c is, I will show example. Okay, there is a way to find out a, b and c. All right, next is if the denominator contains repeated linear factor. They are linear but repeated. You see that x plus a square times x minus b. If they are repeated, here they are all different, but here this is repeated twice, right? In that case, how do we separate that? Is you write a over the first power of that x plus a to the 1 plus another constant b over x plus a square, and then plus c over x minus b, like that. Okay, meaning that if there is a repeated or if any linear factor has exponent, then the idea is you do all the exponents, all the power of that linear factor starting from power 1, x plus a to the 1 plus x plus b over x plus a to the 2 and so on. If there was cubed, if this was cubed, okay, if this was like x plus a to the third, then you do a over x plus a plus b over x plus a square plus c over x plus a to the cube, and then plus d over x minus b. That's what you would do. Okay, that's the rule number 2. And rule number 3 and the last rule is if the denominator contains a quadratic factor. Here all the factors were linear on number 1 and number 2. All the factors were linear, right? But here if the one of the factor is quadratic, then how do you do that? For that quadratic factor you do ax plus b. You don't write just a over x square plus a. What you will do is you will write ax plus b, a linear factor, linear numerator, over x square plus a plus c over x minus b. That's what I am doing. That's how you separate them. Okay, and then if the fraction is improper, meaning if the degree of the top is bigger, then first perform a long division, then use partial fraction for the remainder term. We will see example for that one as well. Okay guys, all right, let us do example. Find the partial fraction of 1 over x plus 2 x minus 1. This is proper because the degree of the top is 0, because there is like 1 is x to the 0, right? So the degree of the top is 0, degree of the bottom is 2, because if you simplify this you will get x squared, that is the highest exponent term. So it is proper. Now both of the factors are linear and they are different. There is no repeated factor, right? So how do we write then? We write 1 over x plus 2 and then x minus 1 is equals to, you use rule number 1, right? You write a over x plus 2, a over the first factor plus b over x minus 1. That's what you do. Okay, next thing you do is you write down the left side is the same, just copy the same thing, x plus 2 times x minus 1, and on the right side you write the same denominator. Okay, x plus 2 times x minus 1, and you do the conjugate, right? You get a times x minus 1 plus b times x plus 2. That's what you get. Okay, you see that they both have the same denominator, x plus 2 times x minus 1, x plus 2 times x minus 1. If you multiply by x plus 2 times x minus 1 on both sides, you will cancel those out, right? So what is left is basically 1 equals to a times x minus 1 plus b times x plus 2. Now our goal here is to find out value of uppercase A and uppercase B. How do I do that? Is just try to pick the value of x that makes one of the factors 0. So if you set x equals to 1, what do you get? This one will be this one will disappear, right? Because if you take x equals to 1, so you pick the value of x that makes at least one of the terms 0, right? Set x equals to 1. Let me write down set x equals to 1. What do you get? You get 1 equals to a times 0, that is 0, plus b times 3, right? So now divide by 3 on both sides, so you get b equals to 1/3. I found the value of b as 1/3. Next, I want to set x equals to -2, so that this will disappear. I don't want to set x equals to 1 again, because you will get the same thing, right? So I want to set x equals to -2. If you set x equals to -2, what do you get? You get 1 again. 1 equals to a times -2 minus 1 will be -3, right? And then plus b times 0, right? Because x equals -2 will make it -2 plus 2. That will be 0. b times 0 is 0, so plus 0, right? So now what do you get? -3a equals to 1. So a will be -1/3. I found the value of a is -1/3, and then b is +1/3. So I plug in here, plugging in that. So what do you get the right side? Therefore you get 1 over x plus 2 times x minus 1. This is equals to what? A is -1/3. -1 over 3 x plus 2. You see that? -1 over 3x plus 2. I just plug in a, value of a is -1/3, and then there is x plus 2 in the bottom, and then plus b is what? B is 1/3 again, 1 over 3 x minus 1. That's what you got. Or if you like, you can write like -1/3 here on the top, and then over x plus 2, and +1/3 on the top and over x minus 1. You can do that way. But you see that product can be written as sum of the two fractions there, right? Now if you need to integrate that, like this, that's what we will see later. First of all, you pick just the integrand and then find the partial fraction and then get that. Now this integral is equals to this integral plus this integral, right? This integral is easy to integrate because it will be natural log of x plus 2, and this will be natural log of x minus 1, and so on. Okay, so that's how we do. That's the idea about this. Okay, and let us see another example that says find the partial fraction of 2x over x minus 1 squared times x plus 2. See that? So you see that there is a x minus 1 is repeated. You see that x plus a square is like it is repeated. So how do I do that? Is you write 2x over x minus 1 square times x plus 2 can be written as a over x minus 1 plus b over x minus 1 square plus c over x plus 2. That's what you get, right? Because if there is a repeated factor, then you do a over the first power of the repeated factor plus b over the second power of the repeated factor. The second power is the biggest power, so you stop there, and then plus for the next factor is c over x minus b. Okay, now again, what do you get here? You get 2x over x minus 1 square times x plus 2 is equals to, now you write the same denominator. Okay, how do you write the same denominator? So it is like you don't need to do the product of that, right? So to make the same denominator, it will be highest exponent, that is the highest exponent of that, right, times that one. So it will be x minus 1 square times x plus 2. That is the least common multiple, right? This is the number, or this is the expression that is divisible by all those three. That is the smallest expression. It is like adding like 1/2 plus 1/4 plus 1/5. Either if you are adding that, then the denominator will be 20, right? Because the 20 is the smallest number that is divisible by 2, 4, and 5. It's like that. Okay, now what you do is you divide this by x minus 1. What do you get? You get x a times x minus 1 times x plus 2 plus b times x plus 2 plus c times x minus 1 square. So you may be curious, how did I get that? That's a good question. So if you want to see that, let me show you that. If you want to add like 1/2 plus 1/4 plus 1/5 like that, how do you add these three fractions? So what is the smallest number that is divisible by 2, 4, and 5? Okay, you need to find a number that is divisible by 2, 4, and 5. So if you multiply all these three, that is also okay, but that is not the smallest one. You see that will not be the smallest one. So the number that is multiplied by 2, 4, and 5 is, you can multiply this 2 and 4. The multiple of 2 and 4 is 4, right? I mean the biggest number that is divisible by 2 and 4 is 4. So forget about 2, just multiply by 4 and 5. That's the different thing, right? Multiply by 4 and 5 is 4 times 5 is 20. Now divide 20 by 2 is, there is 1 on the top, 1 times 10, because 20 divided by 2 is 10, plus 1 times 20 divided by 4 is 5, plus 1 times 20 divided by 5 is 4. And what do you get? 10 times 1 is 10, plus 5 plus 4, 19 over 20. That's what you do, right? To add the numbers. You see that? So I'm using exactly the same technique there. Alright guys, so I use that technique and then I combine the fractions on the right side. As the previous example, what you need to do, the denominator is same, so you can cancel out the denominator. So what is left there is 2x equals to a times x minus 1 and x plus 2, right? And then plus b times x plus 2, and then plus c times x minus 1 square, right? So so you can basically find out these partial fraction videos in YouTube, and also you can look at the watch the video in the website, the books video. Okay, you can watch those too. Now the next thing is you're just trying to plug in the different values of x. So how do I pick the values of x? Is usually you pick the value of x that makes at least one of the factor, one of the term 0. So let me take x equals to 1. If I do that, what do you get on the left side? You will get 2 equals to, that will be 0, right? You will get 3b if you take x equals to, and that will be also 0. So you get b equals to 2/3. This implies b equals to 2/3. So next value I want to try, I don't want to try x equals to 1. You keep getting this same thing. So try different value of x that makes at least one of these terms 0. On the terms on the right side, not the left side, make at least one term on the right side 0. I want to do x equals to -2. If I do that, then a will be 0. On the left side, you will get -4 equals to, this will be 0 because -2 plus 2 will be 0. So 0 times something is 0. This will be 0. That will be what? C times -3 square, because x is -2. -2 minus 1 is -3 square. Right? What do you get then? Then you get -4. This implies -4 equals to what? 9c, because -3 square is positive 9c. So this implies c equals to what? C equals to -4/9. That's what I got. Now you see that I don't have any value of x that makes one of these these three terms 0, because I used x equals to 1 already, x equals to -2 already. Now what I want to do is I want to try any other value of x, okay, and use these values of b and c. Okay, let us try any value of x different from this. I will try x equals to 0. That is okay to try. If you do that, you get 0 on the left side equals to a times 0 minus 1 is -1. 0 plus 2 is positive. So it will be -2 times a, right? And then plus b times 2, because x is 0, plus c times 0 minus 1 is -1 square is positive 1. So it is c times 1. See that? You got 0 equals to -2 twice a plus twice b plus c. Now plug in the value of b and c from there. So you get 0 equals to -2 twice a plus 2 times 2 over 3 plus, oh, it's minus, right? So because there is -4/9, -4/9. Okay, now what do you get there then? So let me move this 2a to the left side. Twice a equals to 4/3 minus 4/9. What do you get? So that will be 4/3 is 12/9, right? I multiply top and bottom by 3 to make the same denominator, minus 4/9. So 12 minus 4/9 is 8/9, right? So twice a equals to 8/9. What is a then? A will be 4/9. If you divide by 2, you will get 4/9. That is the value of a. Okay. Now you plug in back on this line. Okay. Therefore, what do you get? 2x. Let me use different color for that. So therefore, 2x over x minus 1 square, and then times x plus 2, okay, equals to, you get a is 4/9. You can add 4/9 over x minus 1. I'm just plugging in here. Or you can write 4 over 9 times x minus 1, no problem. Okay, plus b is what? Plus b is also, b is 2/3. 2/3 over x minus 1 square, right? And then plus c is, you can write negative 4/9 here, or write this sign negative over, what is that, x plus 2. That is the final answer, right? Now again, so you will see how to integrate this one later, okay? If there is like dx like that, first of all you will get this fraction form, okay? And then integrate each of the term. That will be easy to integrate that way. Okay guys, that is the goal. So in the next video I will show you one more type of the rule, that is rule number 3 type of problem, and then I will show you the integration of this type of equations or this type of rational functions. Okay guys, thank you.